Hello everyone, welcome back to my channel Study With Me. Today I'm going to talk about Chemistry Standard Level Paper 2 November 2021. If you find this video is helpful, please don't forget to subscribe and let your other friend knows about my channel so you can support me. And let's get started. A 4.406 gram sample of a compound containing only C, H, and O was burned in excess oxygen, 8.802 gram of CO2, and 3.604 gram of H2O were produced. Determine the empirical formula of the compound using section 6 of the data booklet. So we've got the mass of CO2 and then the mass of H2O2, So first we need to find the mass of carbon in CO2, which is 8.802 times 12 divided by 44. 12 comes from the relative atomic mass of carbon and 44 is the molecular mass of carbon dioxide. So you get 2.402 gram. And then now for hydrogen, that will be 3.604 times 2 times 1.101 divided by 18.02 because it's H2. So 2 times the relative atomic mass of hydrogen. You will get 0.404 gram. So then you can calculate the mass of oxygen. This will be 2.402 gram. 4.406 minus 2.402, you get 1.6 gram. Therefore, mass of oxygen would be 1.6 divided by 16. So you get 0.1. For C, this one for mole, not for mass. So for C, mole of C would be 2.402 divided by 12, relative atomic mass of nitrogen. Sorry, for carbon, that would be 0.2. And for hydrogen, that would be 0.404 divided by 1.01. You get 0.4. So this is 1, this is 2, this is 4. So the empirical formula will be C2H4O. Determine the molecular formula of this compound if its molar mass is 18.12. If its molar mass 18.12, to find the molecular formula would be molar mass divided by molecular formula of the empirical formula. That would be 18.88.12 divided by 44.06. If you calculate this C2H4O, you'll get 44.06, which is 2. Thus, the molecular formula would be 2 times C2H4O times the empirical formula. So the molecular formula would be C4H8O2. The following spectrum show the infrared spectra of propanol, propanal, and propanoic acid. If you can see here, 3000 for propanol. In the data booklet, propanol, which is OH, 3200 to 3600. 3200 to 3600. So that would be OH, 3000 to 3600. And nothing else. Spectrum B, you've got also 3000 here and something else here around 1700 to 1750. It's C double bond O and this one is OH. So C double bond O, it's propanoic acid because it has C double bond O and OH, and on this also we have OH. But for carboxylic acid is between 2500 to 3000. Okay, And the third one, there is no 3000 here. It's not very sharp, the peak. So there is no OH, but it has C double bond O, which is propanol. So let's answer the question. Identify each compound from the spectra given. Use absorption from the range of 1700 centimeter to the power -1 to 3500 centimeter to the power -1. Explain the reason for your choice, referring to section 26 of the data booklet. So the first one, it's propan 1O, because there's presence of OH in alcohols, peak in 3200 to 3600 centimeter to the power -4. And the second one is propanoic acid. There is carbonyl, C double bond O, and OH in carboxylic acid absorption, peak in 2500 to 3000 and 1700 to 1750. And the third one is propanol, presence of carbonyl, C double bond O, peak in 1700 to 1750. Explain the general increase in trend in the first ionization energies of the period 3 elements in A to AR. Increases number of proton, atomic radius, size decreases. As you go across period, the number of protons in the nucleus increases, because the number of atomic number increases, right? So increasing the attraction between the nucleus and valence electrons, because the number of protons increases. So the number of electrons also increases, but as these electrons are on the same shells, because it's the same period, the valence electrons do not increase shieldings. As a result, the first ionization energy increases. White phosphorus is an allotrope of phosphorus and exists as P4. Sketch the Lewis electron dot structure of the P4 molecule containing only single bond. So that would be P right here, and this P, and right here. So that would be like a pyramid. So it has lone pair here, lone pair here, lone pair here, and also lone pair here. So phosphorus has 5 valence electron, 3 single bonds, and 1 lone pair. Each phosphorus can form 3 single bonds to each P atom, leaving a lone pair. Okay, this pyramidal structure. Write an equation for the reaction of white phosphorus with chlorine gas to form phosphorus trichloride. So PCl3, the reaction will be P4 when it reacts with 6Cl2, okay, and produce 4PCl3. Deduce the electron domain and molecular geometry using VSEPR theory and estimate Cl-PCl bond angle in PCl3. So PCl3, it has 1 lone pair right here and 4 domain. Therefore, electron domain geometry will be tetrahedral and molecular geometry will be trigonal pyramidal, and bond angle will be 100 degrees. Explain the polarity of PCl3. As you can see, PCl3 here, it has a lone pair. It means it's polar. So when it's polar and it has 1 lone pair right here, so dipoles do not cancel. an equilibrium exists between PCl3 and PCl5. PCl3, when it reacts with Cl2, produces PCl5. Calculate the standard enthalpy change for the forward reaction in kilojoule per mole. So Cl2 here in their standard state, therefore the standard enthalpy change is 0. So to calculate standard enthalpy change on this question, from this question, that would be delta H product minus delta H reactant, so that would be negative 398.9 minus 306.4 equal to negative 92.5 kilojoule per mole. State the equilibrium constant expression Kc for this reaction. Kc, that would be product, concentration of product divided by concentration of reactant. State with a reason the effect of an increase in temperature on the position of this equilibrium. Shift towards reactant and forward reaction is S forward reaction is exothermic because delta H is negative 92.5. Why? The reaction is PCl3 plus Cl2 produce PCl5. Delta H is negative. Therefore, forward reaction is exothermic. Reverse reaction is endothermic because delta H is negative. So when the temperature increase, absorbs heat, right? So it will cause the equilibrium shift towards reactant to minimize the change. 1-chloropentane reacts with aqueous sodium hydroxide. Identify the type of reaction. It's nucleophilic substitution. So for 1-chloropentane, so C, Cl, CH2, 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 and CH3, when it reacts with NaOH, okay, this OH will replace Cl, producing pentanol. So it's a substitution. And OH is a strong nucleophile. So that's why the type of reaction is a nucleophilic substitution. Outline the role of the hydroxide ion in this reaction. The role of hydroxide ion is acting as a nucleophile which donates a lone pair of electrons. Suggest with a reason why 1-iodopentane reacts faster than 1-chloropentane under the same condition. Ci bond weaker than CCl bond. CCl bond will not break easily. Ci bond, it will break easily because it's weaker. So Ci bond weaker than CCl bond, as it will break, or as it will break more easily. Why? Because Cl is more electronegative, so it is stronger in attracting electron compared to iodine. So that's why Ci bond is weaker than CCl bond. The reaction was repeated at a lower temperature. Sketch label Maxwell-Boltzmann energy distribution curves at the original temperature T1 and the new lower temperature T2. Okay, so Maxwell-Boltzmann, always the first one will be like this, and the second one is a bit low. Okay, lower temperature. So as the new lower temperature will be T2, and then this will be T1 because this one is lower temperature. Higher temperature always slightly to the right. Okay, so this the higher temperature, and this one the lower temperature or original temperature. This one is lower temperature. Higher temperature slightly right, as more particles have more kinetic energy. So this one has higher temperature. Explain the effect of lowering temperature on the rate of reaction. Of course, rate is lower and kinetic energy of molecule is lower, or rate is lower and less frequent collision, or rate is lower and fewer collision per unit time. Phosphoric acid H3PO4 can undergo stepwise neutralization, forming amphiprotic species. Formulate an equation for the reaction of 1 mole of phosphoric acid and 1 mole of NaOH. If you find it difficult how to produce the product, H3PO4, this is phosphate ion, NH plus. So this one will be Na plus and OH minus. This will combine Na plus PO4, 3 minus crisscross. That would be Na3 PO4 plus H plus and OH minus, always H2O. Alright, so this one aqueous, this one aqueous, this one aqueous, and this one liquid. Formulate 2 equations to show the amphiprotic nature of H2PO4 minus. Amphiprotic means that it able to donate proton and accepting proton, or it can be a base or it can be an acid. So as a base, H2PO4 minus, when it reacts with H plus, will produce H3PO4. And H2PO4 as the base, as the acid, will react with OH minus, will form HPO4 2 minus and H2O liquid. Calculate the concentration of H3PO4 if 25 centimeter cube is completely neutralized by the addition of 28.40 centimeter cube of 0.5 molar NaOH. The reaction would be H3PO4 plus NaOH. Sorry, this one, it's not balanced yet. So this will be 3 NaOH, and this one will be 3 H2O. So H3PO4 plus 3 NaOH will produce Na3PO4 plus 3 H2O. From this question, we can calculate mole of NaOH, which is 0.0284. This divided by 1000 times 0.5, which is 0.01420 mole. And NH3PO4 would be, this mole is 1, so 1 over 3 times 0.01420 will be 0.004733. Therefore, we can calculate the concentration, which is mole divided by volume, 0.025. Coming from here, then you will get 0.1893 mole per decimeter cube. Outline the reason that sodium hydroxide is considered as a Bronsted-Lowry base. because it is a proton acceptor and donor a pair of electron. How? When NaOH dissolve in water, okay, it will form Na plus and OH minus. This OH minus, it will be able to accept proton, produce H2O, or the electron pair here will be able, or it able to donate this pair of electron, acting as a Bronsted-Lowry base as well. So proton acceptor and also able to donor a pair of electron. Okay. Biochemical oxygen demand can be determined by the Winkler method. Outline what is measured by BOD. BOD means amount of oxygen used to decompose the organic matter. A student dissolves 0.1240, the uncertainty is 0.0001 gram of sodium thiosulfate to make 1000 0.4 centimeter cube of solution to use in the Winkler method. Determine the percentage uncertainty in the molar concentration. So first we need to find out the percentage uncertainty in the mass, which is 0.0001 divided by 0.1240 times 100, you get 0.08%. And percentage uncertainty in solution, or V, would be 0.4 divided by 1000 times 100 would be 0.04. Therefore, the percentage uncertainty will be 0.08 times 0.04, which is 0.1%. A 25 centimeter cube sample of water was treated according to the Winkler method. These are the reaction. The iodine produced was titrated with 37.50 centimeter cube of 5 times 10 to the power negative 4 mole decimeter cube sodium thiosulfate. Calculate the amount in moles of sodium thiosulfate used in a titration. So N, C times V. C is known, which is 5 times 10 to the power negative 4 times 0.0375, this one. You get 1.875 times 10 to the power negative 5. Deduce the mole ratio of oxygen consumed in step 1 to S2O32 minus used in step 3. It's 1:4. How? Okay. In this reaction, or in general, Winkler method, where the oxygen reacts with Mn2 plus, okay, these are the reaction. When oxygen react with Mn2 plus and OH minus, it will produce MnO2 by consuming oxygen. So MnO2 then reacts with iodine ion and H plus, producing Mn2 plus and I2, iodine, and water. And this iodine will react with sodium thiosulfate, okay? And the amount of sodium thiosulfate it's used to determine oxygen concentration. Okay, in step 1, each mole of oxygen produce 2 mole of manganese oxide that would reacts with I2, okay, or iodine, and every mole of O2 oxygen in step 1 produce 1 mole of I2 that reacts with 2 mole of sodium thiosulfate. So as you can see, 1 mole of oxygen produce 2 mole of manganese oxide, which then react with iodine ion, and this produce iodide that reacts with 2 moles of sodium thiosulfate. Therefore, 1 mole of oxygen ratio to 4 mole of sodium thiosulfate. Calculate the concentration of dissolved oxygen in mole per decimeter cube in the sample. As you know, is 1/4. So N oxygen will be 1/4 times mole of sodium thiosulfate, which is 1.875 times 10 to the power negative 5. So 1.875 times 10 to the power negative 5, you get here 4.668 times 10 to the power negative 6. And you can find out now the concentration of oxygen, which is N/V, 4.668 times 10 to the power negative 6 divided by 0.025, which is 1.875 times 10 to the power negative 4 mole per decimeter cube. So 0.025, it's known here. Okay. The 3 steps of the Winkler method are redox reaction. Deduce the reduction half equation for step 2. These are the step 2. So step 2, the half equation, it's between MnO2 and Mn2 plus. Okay, let's do this. So MnO2 produce Mn2 plus. As you can see, Mn are equal, but not for oxygen, because there are 2 oxygen here, so we can balance by adding 2 H2O, so 2O. And there are 4 H right here, so that would be 4 H plus. And now we see the charge. Here is +2, and here is +4. To balance the charge, you can add electron, which is negative. So we need to add electron on the left side. So you can add 2 electron, and now the charge will be +2. Next, alkane undergo combustion and substitution. Determine the molar enthalpy of combustion of an alkane if 8.75 times 10 to the power negative 4 moles are burned, raising the temperature of 20 grams of water by 57.3 degrees Celsius. So QMC delta T, that would be 20 times 4.18 times 57.3, you get 4790 joule. So delta H should be divided by mole. So 4790 divided by 8.75 times 10 to the power negative 4, because this is the number of mole, divided by 1000 again, because we want it to be kilojoule. Delta H is in kilojoule. So you will get negative 5470 kilojoule per mole. Why it is negative? Because it's combustion. When it's combustion, the temperature increases, so that's why it is negative. Formulate equations for the 2 propagation steps and 1 termination step in the formation of chloroethane from ethane. Okay, so propagation involves continuation of reaction producing reactive species that can further react, involving the formation of reactive intermediates which continue the chain reaction by reacting with other reactant. So it's producing the reactive intermediate. That would be Cl radical plus C2H6 will produce C2H5 plus HCl. Or C2H5 react with Cl2 producing Cl radical and C2H5Cl. These are propagation. Okay? Because propagation is producing reactive species that can further react, or formation of reactive intermediates which continue the chain reaction by reacting with other reactant. Okay? Now termination. Termination involves the combination of reactive intermediates to form stable product, thus stopping the chain reaction. So it's a combination of reactive intermediate. So we have a reactive intermediate here, Cl. So Cl radical, it will be right here, okay? Cl radical plus Cl radical produce Cl2. Or C2H5 plus radical C2H5 will produce C4H10, okay? Or C2H5 plus Cl will produce C2H5Cl. This is termination. All right. Fast-moving helium nuclei were fired at thin piece of gold foil with most passing undeflected, but a few deviating largely from their path. The diagram illustrates this historic experiment. Suggests what can be concluded about the gold atom from this experiment. Most He passing straight through means because most of the atom is empty space. The experiment with fast-moving the nuclei, He nuclei fired on a thin gold foil, show that most of the nuclei pass through the foil undeflected. This implies that atoms are mostly empty space because of the majority space within an atom allowed the helium nuclei to pass through without interaction. Very few He deviating largely from their path, because nucleus is very small and dense compared to the size of the atom. The fact that only a few nuclei deviated largely from their path indicates that the nucleus or center of the atom is very small compared to the overall size of atom. Subsequent experiments show electrons existing in energy levels occupying various orbital shape. Sketch diagram 1s, 2s, a little bit bigger, and 2p. State the electron configuration of copper. Copper number is 29. So that would be 1s1, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10, or short notation is AR, 4s1, 3d10. Alright, that's all the explanation for the paper 2 standard level November 2021. If you find this video is helpful, please don't forget to subscribe and let your other friends know about my channel to support me. Thank you for watching, and bye.